Okay, students, this video will be here to explain what are some of the things that you have done for the classwork 11.4. And I also highlight certain things that you need to know for this worksheet. So as we go through a worksheet, please do your correction so that you know where you went wrong, as well as what else you perhaps have missed out when you have done your HBR lesson for the last week and yesterday. First off, we have this picture that shows the diagram of the human digestive system. So the very first thing that they point out here is the mouth. And above the mouth here is the saliva gland. So the saliva gland is the organ that will help us produce the saliva, where certain enzymes are also found inside that saliva to help us digest our carbohydrates into starch. Next up, this long tube over here is called the esophagus. So for the esophagus, please make sure you spell it with the letter O in front. This organ over here that looks a little bit like a triangle, this is known as the liver, L-I-V-E-R. The one that looks like a soya bean here, is known as the stomach. And after the stomach, you notice that this portion goes into a very, very long tube. But before it goes in a very long tube, this organ here, right over here, that looks a little bit like a leaf, this is called the pancreas. The pancreas is not in the path of the digested food. Instead, it's actually a organ that assists in the digestion by producing certain enzymes. Next up, we have this small thing right at the bottom of the liver here. This is known as the gallbladder. The job of the gallbladder is to store bile, B-I-L-E, bile. The long tube over here, this is called the small intestine. And once you finish the long tube over here, you go into this larger tube, known as the large intestine. So I hope by now you should be quite familiar with all this. Last two boxes here. You see the large intestine actually exits out into this slightly bigger hole here. And this place where it's slightly bigger is actually known as the rectum. The rectum is the place where we store our feces. And last but not least, this small portion over here, is actually the anus. The anus is where the feces actually comes out of the body. So feces is actually your shit. We don't use the word shit inside our this lesson itself, because that's not the scientific word for it. Feces is the scientific word for it. Next up, which of the above organs are considered accessory organs? When we talk about accessory organs, they are actually organs that are assisting the digestion. The food itself does not go through these organs. So point to take note here. Food does not go through these organs. So this is a point that you need to take note. Food does not go through these organs. Next. So which of the following organs are considered accessory organs? So like what I mentioned just now, there are a few here, that actually the food actually does not go through. First would be the gallbladder and liver. Next would be the pancreas. These three organs is the parts in the center here. The leaf one is the pancreas, the small thing underneath the liver, and the liver itself, the food does not go through. On top of that, if you trace it back to the mouth, Okay, the food does not go into the saliva gland as well. Okay, so the saliva gland is also an accessory organ. Okay, so with that in mind, let's move on to the questions below. Okay, now in this table here, they are actually asking you whether there is physical digestion, whether and what is the chemical digestion, and so on. Okay, so you should be able to find most of this information in the HBL lesson on the small intestine, the mouth. Okay, which is found on the 12th of June. Okay, so let's go into details. Down here, the mouth is actually, there's physical digestion here. Okay, why? Because the teeth, okay, cuts and grinds, okay, food into smaller pieces. Okay, so when we talk about all this, we're actually looking at the food itself. What does it do? Okay, so what happens to the food? So in terms of the mouth, okay, the teeth will make sure that from a big piece, it becomes smaller pieces. Okay, next we have down here, is there any chemical digestion that is happening here? So from what I mentioned just now as well, okay, there is some chemical digestion taking place, okay, where the carbohydrates actually gets turned into starch. Okay, okay, so let me correct myself. Okay, it's not carbohydrates turned into starch, it's starch actually turned into some form of a sugar, okay, called maltose. Okay, so let's talk about it in terms of starch. Okay, starch gets turned into maltose. Okay, so this information is found on the 12th of June HBL lesson. Okay, and the enzyme that is in charge of this is amylase, A-M-Y-L-A-S-E. A-M-Y-L-A-S-E. Okay, so the amylase, okay, will digest the starch to become maltose. Okay, maltose is a type of sugar. Okay, so is there any absorption that is taking place? No, there is no absorption taking place in the mouth. Okay, the esophagus. Okay, esophagus, basically the job of the esophagus is to push the food down from the mouth into the stomach. Okay, so there is no digestion that is taking place whatsoever. Okay, so both physical and chemical digestion will not take place. On top of that, absorption wise, okay, the esophagus does not absorb any form of nutrient. Okay, so its sole job is to push the food from the mouth into the stomach. Okay, next, the stomach. Okay, what does the stomach do? Okay, the stomach actually churns, okay, to break food into smaller pieces. So think of this like pounding the food into even smaller pieces than what we have before. Okay, so instead of the pounding action, the stomach actually churns, which is like squeezing. Okay, so when it squeezes, it forces the food to break down into even smaller pieces. Okay, so for stomach itself, it is only going to digest proteins. Okay, it's only going to digest proteins. Okay, and this enzyme that is in charge of the digestion of proteins is called the protease. So you notice there's a special pattern at the end, okay, where the enzyme actually ends with ASE. See, amylase protease. Okay, so the proteins will be digested into simple protein molecules. Okay, simple protein molecules. Okay, and same as the mouth and the esophagus, there's no absorption taking place for the stomach. Okay, next we have the small intestine. Okay, the small intestine has a number of roles. Okay, but the very first thing that it does is actually the bile, okay, that is injected into the small intestine, okay, breaks down the fat droplets. So this process is called the emulsification of fats. Okay, so the bile emulsifies fats into smaller oil droplets. Okay, because fats is quite a complex molecule, so it's not easy for the small intestine or the enzyme found in the small intestine to digest, okay, into the required products to be absorbed by the body. Okay, so same thing down here. Okay, for the small intestine, anything that the that the mouth cannot digest, okay, will then be proceeded into the stomach, and anything that stomach that cannot be digested will be proceeded into the small intestine, where it will actually digest all, okay, all the products. Okay, so let's start off with the starch. Okay, so the starch, some of the starch will not be able to be digested at the mouth, so this is where the starch will continue to digest. Okay, so of course when we talk about starch, okay, we are going to digest using amylase, okay, into maltose. Okay, so the maltose itself, okay, is going to be digested into glucose. Okay, glucose is the one that the body can absorb. Okay, so the enzyme that can digest maltose is called make a guess? Maltase. Okay, maltase. Okay, so do you see a pattern here? Maltose, maltase. Okay, maltose is digested by maltase to give glucose. Glucose is the final product which the body will absorb. Okay, next will be the proteins. Okay, the proteins that is not digested in the stomach will then be continue to be digested. Okay, and the simple protein molecules will also be digested further, okay, by the protease. Okay, so the protease will be digested into amino acids, where the stomach will then be able to absorb. Sorry, the small intestine will then be able to absorb. Okay, last one will be the fats. Okay, the fats is digested by lipase. Okay, lipase. Okay, lipase is then digested into fatty acids. Okay, and glycerol. Okay, so what is being absorbed in the end, okay, is actually glucose, fatty acid, amino acids, and glycerol. Okay, so these few things will be absorbed. Okay, so I write down here what is being absorbed: glucose, amino acids from the proteins, fatty acids, and glycerol from the small intestine. Okay, now in terms of large intestine does not perform any digestion at all. So there is no physical or chemical digestion. Basically, all digestion will end at the small intestine. Okay, but there is absorption. Okay, so it will absorb water and mineral salts. Okay, it will absorb water and mineral salts. Okay, so what is important here is basically where does the digestion take place, in which part of the digestive system. Okay, and next thing is anything that has digestion, okay, chemical digestion, will have enzymes being produced. Okay, so the enzymes will be the ones that do the chemical digestion. Okay, and in terms of absorption, there are only two places where it will be absorbed. One is in the small intestine, where these products, the glucose, amino acids, fatty acid, and glycerol, okay, will be absorbed. Okay, and the large intestine wise will be water and mineral salts. Okay, actually vitamins is also absorbed in this large intestine here. Okay, so with that in mind, let's move on to question 3. Okay, basically like what we have mentioned just now. Okay, certain places will have certain enzymes being produced because they are in charge of digesting certain things. Okay, so again, okay, amylase is digest starch. Okay, maltase digests maltose. Okay, protease digests proteins. Okay, lipase digests fats. Okay, so with that in mind, let's look at the this table. Which organ or which place, okay, actually digests what thing? Okay, so gastric here meaning gastric juice from the stomach. Okay, this one from stomach. Okay, gastric juice from the stomach. Okay, so let's look at this saliva. What does it digest? So from what we have learnt before, saliva actually digests only the starch, okay, into maltose. So that means saliva, yes, there is amylase, but there is no others. Okay, next, gastric juice from the stomach. Okay, the gastric juice from the stomach only digests proteins. Okay, so if it only digests proteins, so anything to do with carbohydrates and fats will not happen. Okay, but there will be some proteins to digest the proteins. Okay, next come the bile. Okay, the bile, okay, is actually only breaking down the fats into smaller oil droplets. So there is no digestion for this case. Okay, pancreatic. Okay, pancreatic means the pancreas, from the pancreas. Okay, so the pancreas actually produces some enzymes, okay, that will help to digest certain things. Okay, so in terms of the pancreatic juice, it will produce the enzymes to digest this starch into maltose, but it doesn't do the maltose to glucose portion. Okay, it does produce the protease and some lipase as well. Okay, last part, the intestinal juices, that means from the small intestine. Okay, the small intestine actually do digest certain things as well. So they do, what do they digest? They digest the maltose. Okay, this is second part of the whole digestion, right, of the starch. So the maltose will be digested into glucose. Okay, as well as they produce proteins and lipase to help with the digestion of the proteins and fats. Okay, so having said that, okay, let's move on to question 4. Solid food enters. Okay, solid food enters the mouth at P. So you see that this is the mouth. Okay, enters here. So it's like the teeth here, I suppose. Okay, and enters the esophagus at Q. So this one must be the esophagus. Okay, so this part. Okay, so basically the food will go here and through here and go down there. Okay, so how does the food at Q differ from the food at P? So when you look at this question, you need to know that actually the teeth does some form of breaking down the food so that it can actually enter Q, because we know that Q is actually quite small. Okay, the opening of the esophagus is actually very, very small. Okay, so what is the difference? Okay, basically the food at Q will have been smaller pieces, as well as some starch is being digested. Okay, digested by the amylase that is found in the saliva gland that is produced to digest the this starch into maltose. Okay, so let's look at this. It contains, the first answer, it has large particles. So they are trying to say that the food at Q is larger particle than the food at P. So this is not true. Okay, it contains less protein. That is not true, because protein is not digested at the mouth, so the amount of proteins will remain the same. Okay, C, it contains more starch, is also not true. Okay, because the amount of this starch, okay, actually reduces as it goes to Q, because some digestion takes place from P to Q. Okay, some digestion of the starch happens from P to Q. Okay, D is actually the answer. Okay, why? Okay, so basically when food is broken down, okay, when food broken down into smaller pieces, okay, when this happens, we are actually trying to increase, okay, we are trying to increase the surface area. Okay, we are trying to increase the surface area. Yeah, so it's the same as you take a piece of bread, you peel it into smaller pieces. When you peel into smaller pieces, you look around, you actually see more surface area as compared to when you have the bread alone. Okay, so that's why D is the answer. Okay, next up, question 5. Okay, the stomach temporarily stores food, digests and churns it. Okay, so they are trying to describe to you what is happening inside that stomach. Okay, say the purpose of churning the food in the stomach. So like what we have mentioned just now, okay, the purpose is actually to break down food into smaller pieces. Okay, so churning is actually trying to break down food into smaller pieces. It's a type of physical digestion. Okay, part B, state the nutrient that is digested in the stomach. So from what we mentioned just now, stomach only digests proteins, and that's why proteins is the answer. Okay, C part 1. Okay, name the substance in the gastric juice that causes the stomach to have high acidity. So in the this 12th of June lesson, you have learned that the stomach, other than producing the stomach juices, okay, it also produces stomach acid. Okay, and the acid in that case, okay, is actually the hydrochloric acid. Okay, it's one of the most acidic substances known to man. Okay. Now for hydrochloric acid, why does the stomach need to produce this thing in the first place? Okay, so the job of the acid, right, is actually to provide, it has two jobs. First is to kill bacteria. Okay, this is the main job, to kill the bacteria. Make sure that the bacteria that will cause us to be sick is actually killed, okay, as much as possible. Okay, next would be the providing an acidic environment okay for the proteins to work. Okay, these special proteins that is found inside the stomach, okay, these special proteins that is found inside the stomach, okay, can only work in this particular acidic environment. Okay, so without the hydrochloric acid, it will not work at all. Okay, next one, C part 3. Describe how the stomach prevents a substance stated in B part 1, okay, from corroding itself. Okay, so it shouldn't be B part 1, sorry, it should be C part 1. Okay, so basically they are asking how does the stomach protect itself from the hydrochloric acid, okay, the stomach acid. Okay, so basically the stomach is very special. Okay, the wall of the stomach, okay, based on the information I given you, okay, the wall of the stomach has produce a thick mucous membrane to protect it, to protect itself. Okay, so this mucous membrane actually protects the stomach from being corroded. Okay, but of course sometimes people get sick, okay, and this mucous membrane actually got eroded away and it doesn't replenish itself fast enough, and that's where the stomach acid start to attack the stomach walls itself, and this causes stomach cancer and stomach ulcer. Okay, so there are some problems related to it as well, but we still need this stomach acid to make sure that we don't get sick most of the time. Question 6. Okay, the diagram shows the human alimentary canal. Okay, the alimentary canal is basically the digestive system. Okay, another word for digestive system. Okay, this is another word for the digestive system. Yeah, so this shows part of the digestive system. Which two structures produces substances involved in the digestion of fat? Okay, so we want to digest fat now. Okay, but which are the two substances that is in charge of helping that to happen? Okay, so if you look at all these things carefully, one is actually the esophagus. Okay, so we know that the esophagus has nothing to do with the digestion of fats. Okay, 2 is actually the stomach. Same thing, stomach has nothing to do with the digestion of fats. Okay, but if you look at 3, 4, 5, okay, 3, 4, 5, okay, there is some connection. Okay, there is some connection between all these three things. Okay, 5 is the gallbladder. Okay, the job of the gallbladder is to store bile. Okay, 4 is liver. Liver is to produce bile. Okay, and 3 is the pancreas. Okay, like what we've discussed just now, pancreas is producing enzymes to digest the fats, the starch, as well as the proteins. Okay, so if you look at the information that is given, we know that 3 is needed because it has the enzyme to digest the fats, okay, or oil droplets. Okay, now 4 and 5 on the other hand, you have to be careful and look at the function again. Okay, because 4 is producing the bile, 5 is actually storing the bile. Okay, so 5 should not be the answer, whereas 4 should be part of the answer. So because we talk about produce substances, the word produce is important here. Okay, so that's why answer for this is C. Okay, where pancreas and the liver is actually in charge of producing some things that is there to help to digest the the fat, sorry. Okay, so with this we are done with page 1 and page 2.